And welcome to Mysteries in the Universe with Dr. Prem Zaganti here at Vision of Light Ministries. My name is Ryan Holland. With us is Duke Iqbal, founder of Vision of Light Ministries, and of course Dr. Prem Zaganti. And we have a very special guest with us today, Joseph Kalpala. Welcome to Mysteries in the Universe.
Thank you.
And Dr. Prem, we're going to be talking about some really cool scientific stuff today, obviously, where we're going to be hitting on some solar and lunar eclipses. So do you want to just kind of share with us a bit about what you're going to be talking about today?
Yes. As part of this Mysteries in the Universe part, we want to concentrate just on one aspect, that is the sun and the earth, how the moon goes in between and away from the in-between position. We call lunar and solar eclipses, and we're going to talk about that one today.
Okay, that is fantastic. Looking forward to that. Duke, do you want to introduce your friend, Joseph?
Well, Joseph is a good friend of mine, just like Dr. Prem. We've been knowing for 20-something years, and we've been in the fellowshipping doing a long time. He's heavily involved with the community, also the church, and he also does a lot of things for helping people out. He's a very nice man, and I'm glad to have a friend like him.
Oh, absolutely.
Same here.
Okay.
And Prem too.
Yeah, of course. Well, very good. Well, do you want to go ahead and get rolling on your presentation today, or at least introduce it? The floor is yours, Dr. Prem. So how would you like to take us from here?
I would like to share some of the slides that I put together.
Okay.
And also show my software that we have been using in the past few episodes. And I want to show you the evening sky and take you back and forth in that one, and we'll discuss on those things. As you ask the questions, I will pause and answer them and then move forward.
That's fantastic. I would love to be an astronomer in another lifetime. So I love the stars, love studying and learning about the stars. So I'm particularly excited about this episode. So yeah, let's do it.
Everything okay?
Yeah. Before you head out, I have one more question from last episode. And as you said, if we look at out in the sky, it's blue, but when you look up from the moon, the sky looks very, very dark. And I got to think of myself, man, that's going to be pretty scary. You look at from there, and everything is so dark. Is there any lighting when you look at from moon to side? Just like in the daytime, we look at the sky is blue. It's the same effect in the nighttime from when you look at from the moon to the sky?
Yes. On moon also you have the same sunlight being projected, and you will feel on this side of the moon facing the sun or facing towards the earth, you will get to see the light there. That's a wonderful thing there. And the beauty is on the earth we have this atmosphere. That is one bubble. And beyond that bubble we have one more thing called the magnetic lines of forces that protects us. On moon, neither magnetic lines of forces there nor the atmosphere. There is no atmosphere on the moon at all. So on the earth, because of the atmosphere, when the light comes from the sun, considered to be, Newton said a long time ago, white light consists of 7 colors. You call them rainbow, right? In the same way, white light from the sun is coming through, and when it hits the atmosphere, violet, indigo, blue, yellow, orange, and red, all the 7 colors, the violet, indigo, blue being on one end of the spectrum, they scatter quickly, and then you see the blue color of the sky. On moon, you have no atmosphere, so there is nothing to scatter. So when you look outside, into the other side of the sun, you will see a black velvet part of the sky. And they have taken pictures of the earth from that black velvet part, and they saw the earth being with lots of clouds and an ocean, blue color. They call it a blue marble.
So when the sun hit that moon, and if you look at that aspect to the sky is still looking dark? Or?
Sky will be looking dark on the other side, yes.
Right. But how about the light side?
When the light is there, it's too bright because the moon surface is a powdery material and reflects so much light. Even today, when we look through the telescope, certain days it will be so bright because our sky is clear, number one. Number two, when moon is closer to us, I'm going to talk about that one today, it is going to be too bright.
Oh, okay. All right, the floor is yours, Dr. Ben.
Thanks very much. Thank you very much. Look forward to the discussions today. And I will be setting up myself here. And am I okay?
Sure.
Everything. So what I have right now is the title slide for us, and we want to talk exclusively on eclipses. We're not talking about various eclipses. Eclipses can occur for other planetary bodies, and even our own spacecraft have seen. Even the Apollo astronauts, when they were traveling Apollo 12, they turned back and they were able to see the eclipse of the Earth coming in front of the sun.
Oh, wow.
So now we are going to look into some of those interesting things here. On my next slide, you are going to see all those important events during 2021. We listed about 4 of them here, 2 for the moon and 2 for the sun. And then the one that we had in the month of June is considered to be partial solar eclipse. And now, just on December 4th, we had a total solar eclipse. Sometimes partial, sometimes total, because something is coming exactly in front of the other object there. And then we have the same thing. Lunar eclipse is going to be May 26th. We had 1, and that is a total lunar eclipse, which means we are actually seeing the moon going through the darkest part of the shadow of the Earth. And then recently, in November 19th, that we have seen part of that one in a partial solar lunar eclipse there. Because it is trying to enter into complete shadow, but 3%, 97% inside the shadow, that's why it's called partial there. So in this case, even 1% is partial.
And you said last episode that the next time happen again from 600 years after?
About 600 years. You're right, Duke. You remember that one very well. Last time I said that it was taking a little bit longer time for us from Houston, about 12 o'clock in the midnight till about 6 o'clock in the morning. We are able to see the faint shadow entering, the moon entering the faint shadow, and then going to the dark shadow and coming out of the faint shadow there. So the total time it took for moon to traverse through these shadows is about 6 hours plus few minutes. And that is, we are able to see that one because of the sun rays and the moon setting down. We could not see part of it, but that's the longest time. So somebody said, how long is this one compared to the longest one we had in the past? They went back about 585 years. So next time we want to see this longest one of all the shadows going through, the moon is going through various parts of the shadows there, you may need to just wait 600 more years. So we're talking about 2600. If you are there, make sure that you verify and let us know what is going on.
I'm going to write it down that from it'll be another 6th generation.
Now, of course, yes.
So I'm going to write it down from my next 6th generation, but they are able to see it.
We're going to have a lot more lunar eclipses, a lot more solar eclipses, but they're going to be shorter ones that people can see, no matter from which part of the world and so on. So these are the millennia eclipses we're talking about, the longest time and so on. Yeah. So on these things, December 4th was the solar eclipse. 15 days before was the lunar eclipse on the November 19th there. I will take you there and show some of these things as we move forward. But I want to give a little bit of orientation of what we are talking about. And here, on this one, you can actually see the distance from Sun to Earth is about 93 million miles. You may not see that number there, about 150 million kilometers there. So to make our life easy, we will say that is 1 astronomical unit. So now from there, if we go further away, you got Mars. You got further away, you got Jupiter, Saturn, and all those things. So Jupiter is about 5 AU, which means 5 times the distance from Sun to Earth. And Saturn is going to be about 10 times the distance from Sun to Earth. That is much even further away there. So we can make this one about how long the light will take to travel from Sun to Earth is about 500 seconds there. You saw the number there, 150 million kilometers the distance, and the speed of light is about 300,000 kilometers per second. And then if you can divide by that one, you get about 500 seconds. 500 seconds is nothing but 8 minutes and about 20 seconds extra there. 8 minutes and 20. So you keep that one in the perspective now. And when we go to the distance from Earth to Moon, it varies and changes slightly because the Moon is also going around the Earth in an elliptical orbit, sometimes closer and sometimes further away. And we're going to talk about that mysterious thing also in the next few slides here. As you can see here, and we are talking about 400,000 kilometers. So the 400,000 kilometers is only 1.25 seconds. So the sun to Earth is about 8 minutes there, 500 seconds, and here you're going about 1.25 seconds you get there. And if we say something about people on the moon, they get about 1.25 seconds later, and they will say, Houston, we have a problem. And then we hear 1.25 seconds later here. And to communicate that one, they came with the idea, Houston, we have a problem. Roger. That's the end of my sentence. Now you can hear and you can respond back. Yes, Ryan, you want to say something?
Well, you just hear about some of these stars that apparently the light from them, I mean, it takes what, I don't know, thousands of years, billions of years for the light to travel and to reach us, for us to see that light. So to me, if we're saying it takes 8 minutes roughly for us to see the light from the sun, or 1.25 seconds to see the light from the moon, yet it takes thousands, millions, billions of years, I mean, for us to see the light from these certain stars. I mean, to me, that really speaks to the really unfathomable enormity of the universe, right? I mean, it's mind-boggling. It's almost incomprehensible.
It is. It is incomprehensible, and it is mind-boggling. And you said we are able to see light from distant objects there. So now we will convert this speed of light and into distances there. We actually say this object is 1,000 light years away, traveling at the speed of light, not just few minutes, but for 24 hours, 7 days, 52 weeks, 365 days. We call that distance as light year. It takes light to travel that much distance. It takes time, so much time. That is at the speed of light, you will reach that particular point in the distance there. So you're right, we have thousands of light years away, millions of light years away. We're going to do one episode exclusively on these distant galaxies. We're going to show pictures of these galaxies there. We're going to talk about all those things here. And some of them are 300 million light years away. Some of them are 1,000 light years away, and so on. And also, these galaxies are so wide. We're not going to tell the dimensions in kilometers. We're going to say how long it will take for you to travel from one edge to another edge. We're going to talk about 1,000 light years, 10,000 light years. These are all in the distances that we're talking about. That is a very interesting question. The other important thing, as you said, Ryan, how far we have seen so far. So NASA got these Hubble telescopes, and then the Hubble telescope was able to it goes around the Earth every 93 minutes. And then now you come to this particular orientation, open your eyes and then close your eyes. Go back and open your eyes and close your eyes. Like about 90 days they did that one. So they are able to see and concentrate one particular object very, very distant, the farthest one. And that is about 13.4 billion light years away. So we know a small sliver how far we can go. Maybe beyond that, something else there we don't know. And that is just one line of a huge sphere. You take a basketball and put a small pin there, and that is the pin that you have seen so far. You may take millions of years just to see the whole set of things here, and we may not have enough data storages for all those things there, but that's how deep we can see. That's how deep we have seen so far.
Wow. So when you went that deep, anything else that NASA saw?
We're seeing all these galaxies being formed, and the stars being cradled in these galaxies. That's what they call the cradle nursery of these stars, just being born and being spread out. So the galaxies are being prepared, are born, and they're spreading out, and it's going to expand for millions of years before they can really become a galaxy that we can say this is a complete galaxy. We have also seen some of these older stars, the big massive stars, collapsing on their own and dying. And that one we call as black holes and things like that. We have seen those things. And we have noticed that one.
Now you say we've seen those things. I mean, doesn't that happen over a very long period of time?
Yes, very long period.
So how is it that we've seen those things? If it takes, I don't know, how long does it take? I mean, hundreds of years, thousands of years? So we're able to maybe see or detect it a little bit, and then we can kind of calculate out like the full thing, or how does that work in terms of us seeing it?
What we are seeing now probably happened thousands, millions of years ago. The light is taking this time to come to us. We are able to see and comprehend that one. When we actually see some of these things, as I said in the beginning, there is a process in the scientific community that these things are expanding. We see one spectrum of the color.
Mm-hmm.
And we also see when these things are collapsing, a different spectrum of the color. For example, the red color and the red tinge and orange tinge, when we see, we know it is expanding. So we come back and look at that one 3 years later, 4 years later, and we can notice that it's actually expanding. We actually saw double stars. These stars, they go around and they are separating themselves. As I mentioned in the beginning, the distance from Sun to Earth is 1 astronomical unit. In our small telescope, we can see they are about 200 astronomical units apart. That is talking about starting from Sun, going to Pluto is only 40 AU, 80 AU, and then beyond that one, 200. And then 4 years later, we notice that it become 400 AU. So it is expanding. That's how we can do that.
Okay.
And it gives the orange tinge there, saying that it's really expanding. And some of them are collapsing on them, and we get these violet and blue tinges there in the spectral property, saying that they're going to collapse and die and so on.
Wow, very good.
That's the fascinating area there.
Oh yeah.
Wonderful. So let me continue on this one. I want to show you the evening sky. And when we talk about the Sun, Earth is going around the Sun in an elliptical orbit, so to speak. So sometimes it's closer to the Sun, sometimes it's further away from the Sun. What we need to know is, it's going to be a tricky question, but because we are following the series here, we want to make sure that you all get this part of the story there. During winter time, we are closer to the Sun. During summertime, we are farthest from the Sun. As you can see on this one, on this part, I have not given the time for you. The January-December time frame, we are closer to the Sun. And the June-July time frame, we are farthest from the Sun. And just keep that in mind. So winter time, we are not farther away from Sun, but we're actually closer, because the tilt of the angle away from the Sun for the Earth, that's making all the difference of the seasons for us. So keep that in mind. And now we have a moon going around the Earth, also going in an elliptical orbit, not a circle, perfect circle, but slightly elongated circle. And because of that one, we have the closest point from Moon towards the Earth and the farthest point from Moon towards the Earth. And these 2 points are always precise. If it comes any closer than what the closest point is, things are going to be disastrous. Because some of you actually go to sea and say that this is a rough sea, and some of you actually say this is a high tide. And these high tide and low tide are actually manipulated by the position of the moon around us. It could be low tide for us, and it could be some other part of the world, it will be high tide. And it changes depending on where the moon is on a daily basis. And now, that is very important for us. If the moon is closer a little bit, the high tide is going to be even higher, which means we may likely to get a tsunami. Somebody said if the moon comes even closer than 1 kilometer, we may get tsunami twice a day. That is going to drench the whole world. I don't think we can handle that one. And that may be the end of the story.
So it almost seems like it's possible that someone may have placed the moon, or some intelligent mind, creator, may have placed the moon at just the right place so that the Earth does not flood.
That's right.
I mean, it seems almost, and we talked about incomprehensibility, I mean, the idea that the moon has to be in such an incredibly small range. And of course, that's one of many things that have to be just right, I'm sure, as
Exactly.
you know and have talked about and we'll talk about on future episodes. It is pretty amazing that the moon is where it is, and if it was barely any closer, barely any further away,
Things can be different.
very different.
I'm going to show that one. And that particular orientation of moon being closer and moon being farthest on that elliptical path, very precise too. I want you to remember 8.85 years.
0.85.
It comes to exactly the same location. I'm going to show the animation to you very quickly on that one.
Let me ask you one question besides that. flooded? It's a biblical type question. So you're talking about when the Noah time, the whole ark went underwater, so you meaning that the moon came close to the ark, and that's how the whole wall got flooded and everything washed away?
Well, in the biblical times, it says that rain came from above. They have not seen it before, so the rain came from above. It is quite possible some of these things could have regurgitated the ocean enough to sand so much. And if you go back to the Genesis part, it says, in the beginning God created the heavens and the earth. And if you go further down, it says, He separated water from water. In other language, it says the firmament. Water on the ground is water. Water in the clouds is also water. But that is in a different form, different position there. How it happened? Only one who knows how to handle these things can create that way.
Yeah.
So that's what I believe, that's what we all believe as well here. Yeah, you're right. It is very, very possible that the regurgitation must have created with just a few inches or few kilometers. Either way, it can cause the problems there.
Speaking about that, in the scientific world, that some of the old city, went under the water, and then was water before is now becoming land.
Yes.
Have scientific way, have you guys figured out how that happened or what that caused?
Well, yes, scientifically we have places that are actually drenched under the ground with lots of material and things like that one. And in fact, I have seen one such thing. They have people built in different shapes of terracotta in China, everything underground there. They place that way, and they always wonder, maybe they are all on the top of the ground one time and they went underground. And it's fascinating to see. And we have places in Europe also, we have cities underground. And all those things built probably above the waters one time, and now it went down. And we know places like Venice and everything, they're going underground. And then even the Netherlands area, they're going underground because the seawater is raising up there. We know all these things can happen as well, scientifically speaking. And those are important things that we know and we have seen already. And those things are going to question us how these things happen, how they build these things, and how they are able to work around. So those things we'll talk about in one of the other episodes, how these things are going to cause those kinds of calamities as well. So, and then one last point here is, if it is closer, it can cause more damage. How about if it is further away? People may think there is no damage there, but if the moon is away, the regurgitation of the ocean's bottom part is going to be almost negligible. If that is negligible, the sedimentation is going to form quicker and faster. If that is the case, the body of the volume of the water is going to raise and raise, number one. Number two, life underwater, deep inside, may not survive and sustain. If that happens, it's going to be even more disastrous for the survival of the humankind in a different way. I think there are some nations, they need to have fish every day. And they may have some difficulty finding enough fish for all the people and all those things there. So that's what is important thing for us. We'll go very quickly here. I want to show you some of the pictures of the moon here. And this is actually the picture of the moon put together from 13 different shots of the moon taken by the spacecraft called LRO, Lunar Reconnaissance Orbiter of NASA there in 2010. You can see that one. And I'm just showing the picture there. And the important thing, interesting thing, we have the darker valleys there. And you have the brighter peaks there and so on, all those things. These names were given not by us, but people in the 16th century. They got moon as the greatest object to see on a nightly basis. And these astronomers got these telescopes. The telescopes, they built with two glass pieces. And they go to the sand in the ocean and they curve them, which means they take a glass piece and make it into concave. And sometimes when you rub on the outside, it becomes convex. And they were playing with these glass pieces, and they can see something distant object closer, as well as bigger, magnified images they could see. And they have seen these things, and they were amazed at the fact that they could see the same spot on the moon all the time. Moon is rotating. Moon is also going around the earth. the rotational part and the going time around the earth is same. So we will see the same face of the moon. As the moon goes around the earth, it makes its own rotation there. And that's why we see the same face of the moon all the time. And it's the same place, or the same side of the moon. We sent astronauts in 1969, 72, and they all landed there. I think I have the picture of that one. But this is a picture taken up close by these $1 billion+ equipment and the spacecraft that we call. The purpose is to get the highest resolution in the shortest or the smallest area on the moon, and we have a beautiful topography of the entire moon there, which we did not have in the 60s when people were trying to land there. Now we have it. Now we even have even better data about the surface of the moon, and we want to land there maybe in the next few years. People are looking from all around the world there. So I want to show this picture to you. This picture is actually taken from the backyard, from my backyard in Houston. We have a lot of pollution of the light in the sky. So this is a small telescope. So my son was helping me, and then we actually went in almost the 2010 time frame. So I thought I want to show these pictures to you today. You can actually see the surface on the right hand side, the craters and everything there. On the previous picture, we have the similar data there, and they all match with everything we see here. And I want to show you one more picture from the same evening there, and that is the area, the middle part of the area, the square red, the red box, the rectangular box I'm showing there. On the right hand side, you actually see all those valleys and the depths and the craters on the moon, and we can see all those things as well there. So here is another one. Now we'll move about 10 years later, and I took this picture about 2019, and we have this new telescope, and we thought, okay, we'll try how the moon looks like in the evening sky, not even in the night yet. And we are able to see the same thing. The moon is going to look the same for us all the time. And that is the near side of the moon that is closer to us, or the face of the moon that is facing us. And we don't have a dark side of the moon. We call that one of the other side, far side of the moon. People used to call the dark side because they thought it's not going to be bright. But when it comes towards the sun, it also gets the light as well there. In fact, recently, there is a new spacecraft landed on the other side of the moon. And communication from the other side is difficult towards the Earth because you are blocked by the entire surface of the moon there. But they were able to get the data and they get the information as well there. We're going to talk about those spacecrafts one day. But let us go back and look at this 1969 picture there. As you can look at the surface of the moon, you can see so many footprints there. As we go by from one mission to another mission, we have so many steps at different locations, and they spend a lot of time as well. And this is of course from Apollo 11, 1969. Neil Armstrong is ready to give a salute for the flag there, and he prepared that one. There is no air or atmosphere, it's all vacuum. That's why they got to devise a way so that they can hold the flag appropriately, not only the pole up and down, but in a horizontal piece to hold it there. And that's what it looks like. And if you go tomorrow, if Duke wants to take our good friend today, Joseph, and walk on the surface of the moon, they are going to see all those footprints, along with their own footprints there. They are never going to change because there is a vacuum, no atmosphere, no weather to change anything there. And look at the sky and the background there. Now, do you believe the sky is black or blue there?
Black. Looks
all black, complete black there. That's what it is. And we are able to see the stars from there. We are able to see some of the other planetary bodies from these particular missions there at the time. And we have another telescope now, we actually can see those things as well. And we get lot more information about those things from the same size of the telescope as on the Earth. On the Earth, we have the atmosphere and all those pollution, light pollution, everything that can disturb the images there. So we work with all those things to get better data for the deepest object there. And this is a picture from NASA's website here. As you can see, 1, 2, 3 on the right hand side. And there's one more at the bottom part and 2 on the left there. All those Apollo 11, 12, 13 did not land there. They went all the way to the moon and returned back. That's the picture they made, Apollo 13. And we got 14, 15, 16, and 17 is the last one on the right hand side. You can see those things there. All those missions insignia is also represented here and so on. As you can see, when we look at the face of the moon, we try to land at different locations. We do have samples of these soils back on the Earth. Some of them are open and did a lot of research, and some of them are still encapsulated and put in the walls there, and they live, most of them in Houston area or in San Antonio area and other parts of the world, and they are representing what we have on the surface of the moon. A little bit deeper into the moon's surface, and we have not seen anything new other than what we have on the Earth there. We can actually recreate the simulated soil of the moon for people like us to do research, how it is going to weather over the exposure of the sun, over the radiation that we did not talk about yet, over time period. And we do that kind of research so that we can have people like Duke and maybe Ryan one day, along with Joseph, walking on the moon and coming back safely to us. Remember, it only takes about 3+ days to reach moon and 3+ days to come back from the moon. If you want to think about the same thing, if you want to go to Mars today and come back, it takes about 3 years or 1,000 days.
Each way?
Each way is about 9 months or 7 months.
Okay.
But if you go there in 9 months and you can't turn around and come back because you miss the Earth. Earth goes around the sun once a year. Mars goes around the sun every 2 years. So that you got a bigger path and you will be running faster, and you will have no opportunity to come back until you wait for an opportune time to return.
Okay.
That brings you to a total of 1,000 days travel there. That's what we are looking forward, and hopefully we'll have some people to go. Now let us go back to this part of the story here. As I said, this is the Earth. This is my simple cartoon illustration for you. Earth is to the scale as big as that blue dot in the center, and moon is about to the scale 1/6 the dimension of the Earth, and so far away to the scale on the extreme right side there on the top. So the path is going to look like almost a circle going around the Earth, but slightly elliptical there. And as you can see, the closest part we call that one perigee, and then farthest point we call that apogee there, and then we have about 36,000 kilometers difference between these two. So on the next picture here, I'm going to show you, if I can give a not to scale imagination for you all, moon is going to go around the Earth in an elliptical orbit. And it is going to have an elliptical orbit is going to change constantly because Earth is going around the sun as well. So it's not going to be at the same location. It's going to move and trying to catch up with that one. The distance is going to be maintained precisely. If it did not maintain, things can be disastrous. We may not have any next episodes. We are done. We are thankful that it is a precise location as ordained or as placed, as Ryan mentioned. It is there. That kind of intelligent part is there, and we're going to see that one. And that is the moon's orbit as we see that one. And the precision of this orbit going around is called the apsidal precision there. A little bit of technical word there. We will skip that one. We'll get to see. Now I'm going to play how long it will take to come back to the same spot here. As you can see, moon is going around on that pink line around the Earth, and it is coming closer and further away. As you can see, it is making that path now. As you can see on the left hand side, you are looking actually on the top corner, left top corner, the year changing there. Now we came to 2018 again, and we are going 19, and then you can see 20. As you can see, this particular precision is making a clear-cut, distinguished lines of inside and outside. Moon is always going to be between those two lines. If it is anywhere closer inside, disaster. If anywhere away from outside, disaster. It never happens. This is called the 8.85 years of this precision there. And that's what we talked about in the previous thing here, 8.85 for the revolution. Once every 8.85 years, it comes back to the same spot. And that's what is going to happen here. It is going to start like that, and you can see, if you can pay attention to the dot, the pink dot on the right hand side, after 8.85 years on the calendar there, it is going to appear exactly at the same location there. That's what I call precision there. Yes, Ryan?
Now, how wide is that range?
That ring is about 36,000 kilometers.
Okay, okay.
And then the closest point in the previous chart, I had the numbers for you, and that actually gives you the distances there. If you can take those things, they're about 36,300 kilometers. That is the dimension of that particular radius. Very good question. So now, how it looks like? The biggest one is when it is in the inside of that line. When it is moon is very close inside, we call that one as super moon. I don't think they thought about any other super things happening in those days. Moon seems to be bigger today. Well, moon looks really big when you are actually driving from Austin to Houston on a full moon day, because you are coming down on this higher altitude to the lower altitude. You feel like moon even before it is completely up for us to see in Houston. You can see from there, and that's how big it looks like. 14% bigger and 30% brighter. Ryan was asking the question at the beginning, is it going to be bright? Yes, it's going to be too bright at this time for the naked eye. Actually, you feel that you can't see anything for a few seconds once you look through the telescope on this full moon called the super moon. When the moon is on the outer ring, we call that one as a micro moon. It's not a micro, but that's the name they gave, so we'll go with that one. There's a smaller moon of that one. So these things are very important when it's coming between sun and the earth. It could be a big supermoon, or it could be a micromoon further away from the earth. What happens is the story for the next few slides that we're going to see here. And I don't know whether you like this picture or not, but I love this picture because this picture is taken from Greece, where my daughter and son-in-law are there. And I was there in the month of June, and in the June month, also supermoon, we had a total, not a supermoon, almost a supermoon time there, and we had an eclipse there, solar eclipse at the time. It's called annular solar eclipse because it is closer to the earth. Now look at that moon, how big it looks like. It looks enormous here, and my daughter saw this picture and said, "Dad, you were talking about this one." She said to me,
beautiful,
and I got that one there. This is a beautiful picture there, and if we send Adam with the camera, he will get the same picture too. No telescope yet. We'll get that one there. So now let's go back and pay attention to sun, earth, and the moon in between here. And this is how it is going to look like for us. Earth is going around the sun on the blue line, and then we got moon going around the earth on the green line there. And the eclipses are not happening every 15 days because we have full moon, we have a new moon, we should have eclipses, but they're not happening. They're not happening because the green circle that is actually going on this blue path is not exactly aligned there. And this is where we need to say it did not happen almost instantly for some unknown reason, because it is precisely placed like this one. If you can look at this green circle and the blue line there, they are slightly tilted. How they are tilted, I'm going to go to earth now and put the moon on the right hand side and see where it looks like in this picture here. Now earth is there, and now I have a blue line going from the earth, the center of the earth, all the way through from left to right. That is the line that is actually going all the way towards my left to the sun. Sun and earth are on this plane now. If you can imagine a tabletop here, they're all on the same table. Sun is on one side and earth is on the other side. Whereas moon is not on the same tabletop but slightly tilted. How much it is tilted there, I think we can actually see that angle there, and probably one of you can tell what is the angle there. I will put my cursor there. You can actually see the number there. When this is the number that I'm asking you, what is the number there? I think Joseph already got that one.
Yeah, the 5.14.
5.14 or 5.14 degrees. Just 5 degrees, slightly more than 5 degrees. Because of that, we have the eclipses only once in a while.
Wow.
Now the alignment of this other ring that we are looking at here in this one, the green one, to the path of the earth, when it matches the 5.1 degrees, comes back and aligns, it happens twice a year, or we call eclipse times, and I'm going to show that one to you. That is what I call precision here. On this one, I would like to say one more thing for you. Very easy to remember. We talked about the dimensions of distance from earth to moon. If earth to moon is 1 let us say 1 unit right now, and the diameter of the moon is about 1 unit, for example. When you turn other way here, the distance from Earth to Sun is 400 such units. The diameter of the moon is 1 unit, whatever it is. Now it could be a kilometer, 1 kilometer. When you turn around to the Sun, it is about 400. Look at the ratios here. The ratio, that distance from Sun to Earth and Earth to Moon, is 1 to 400. The diameter of the Moon to the diameter of the Earth, 1 to 400. Because of that, when we have the eclipses, it covers completely. And those things do not happen just because somebody else threw 2 balls into the air. If that happens, every time we will have a Super Bowl winner, only for one team. It is not going to happen, right? So that's what the story is here. Let me magnify the part of the moon orbit and the Earth there. This is how the 5 degrees are going to collide with one another and make it as a nodes there. They are going to cross. Sometime one in the springtime and one in the fall time. Say for example, April, May, we talked about the important events there. We have Lunar Eclipse and Solar Eclipse in May and June. And then we have Lunar Eclipse and the Solar Eclipse November and December. We're coming to that point right now. And we're going to see this one when they're actually having those orbital alignment. We'll have the eclipses coming on. Other times, the shadow of the Earth is going to go somewhere. The shadow of the moon is going to go somewhere. Moon is not coming in our way between Sun and Earth to have the eclipse there and so on. It's very, very important to know that one here. So going back to the lunar eclipse of November 19th here, just last month, we had a huge shadow of the Earth casting on one direction, and the moon is entering in its orbital path, the penumbra, the faint shadow, the darkest shadow called the umbra, and then coming out. And this is what we said, from one edge to other edge, it is going to be like about 6 hours plus, the longest that we have seen at the time there. So I'm going to show you how it is going to enter into that one here, and that's what we have. The faint shadow of the Earth, now the moon is going to enter into that shadow. When the moon is entering, the shadow orientation is going to change, and then we have the full darker part of the shadow. And in the darker part of shadow, which color we are seeing there? Is it going to be anything? That is going to be almost the shadow is entering there, so we are seeing the moon surface. Now we enter the second part of the darker shadow there, and we are seeing any color there. Do you see a blue or a pink or orange? Almost like reddish color, right? And then you can see the lower part of the moon surface is not covering any shadow here. That's why it is a partial eclipse. 97% of the moon surface is covered there. And now we're going to see, now we're coming out of that one, you can actually see there is still the faint shadow still here that is going to cover on that one too. So I'm going to show this thing on an animation on our own thing here. I set up that one for a minute for us, and we'll see that one. And now on the other side of the story, which is the solar eclipse, we'll come to that one in a minute here. But let me go back to the software here that I have, and I want to show that one to you, how it works and so on. So Adam, if you can give me 1 second here, I'm going to go back to my part here, and I'm going to show this one here, and this is going to be the moon part. So in this software, what I did was I set up the date November 19th here. It's about 1 o'clock here, and I can actually go back here on this one. Let me see here if I can get that part of the story here for you quickly. And okay, I need to get this part of the story here very quickly. I think I messed up that one. That is 1 o'clock. So let us go back to 12 o'clock here, almost 12:59. Do you see anything on the moon? I can actually show it to you. That is how it is going to look like. Moon is really clear. Nothing, no shadow there. And I'm entering into this one, and I'm going to slowly I'm changing the time to backwards now. I'm going to about 12 o'clock and it should be going to 11 something here. About that time, the moon actually experiencing the faint shadow coming over there. And so now I'm going to go quickly here and then give that impression for you. Now we are actually entering into the faint shadow. Do you see on the top left, it is changing the color. Top left is coming on, and towards the right side you see that one. Right, let me move this one. Do you see that part here? Mm-hmm. Do you see that part? There's still a faint shadow. Mm-hmm. What do you see now? Now about 1:28 in the morning, and the shadow of the earth is coming up quickly, and it's going through all the way through. And I like this particular aspect of the software. Actually got the telescope set up there. Do you see the color now? It is going to be a little bit more orangish color. Yeah. Mm-hmm. And then you can actually see the 97%. This part is still missing there. My software is covering on that one. And just a second here. And about 3 o'clock, we have this pinkish moon. If it is a total lunar eclipse, you will get even brighter red color on that one. We'll see that aspect as well. Now we are going to go through almost the shadow is moving away now, receding part. Remember, you still have a faint shadow following this darker part of the shade there, and is going to come. Let me move my part of the story here so that you all can see the shadow coming out here. It's about 4 o'clock now, and then 4:30, 4:40, 4:08, 4:50, 5 o'clock in the morning. And then whether you like it or not, about this time, there is a faint shadow moving away here. There is a small part of the shadow here, covering from this end to that end here. Just watch on that one. You may be able to see the faint part of the shadow going through. The shadow is still there. And now, this is not a shadow because now moon is setting down. I have my own trees and other things causing the problems and so on. So that is the beauty of this particular software for us. I will close up this one so that I can get back to my other part of the story here. Let me see how far the moon is away now, and you can actually see the background of these things here. And then that is the time that you're actually seeing that one. And then I can actually take you a little bit further away, and when I take away my telescopic view on that one, and this is how you're going to see behind the trees the moon is going to set. For you, if you were not having any trees there, you can actually see that part of the moon, and then it goes down. Over time period is at 5 o'clock in the morning, and then probably about 6, everything is almost gone there. You cannot see the moon anymore there. That's why it is about 6 hours and 4 minutes time frame for us in Houston to see the entire eclipse, the longest part, probably 500 years ago, 585 years ago, and you got to wait 6 and more years to see the longest part of the story there. As I change this one back to our part, I'm going to quit this particular part of this one, and then I'll come back to this one. Any questions for me? This is what we have seen so far.
I was curious about the software. Is this is this software that's accessible to a lot of people?
Yes,
it is. Okay.
It is open software. Anybody can download on that one and download that one. You have a lot of other software.
What's the name of it?
The name of the software I use was Stellarium. Stellarium.
Okay, Stellarium.
You can get on your phone. You can get on your PC. Anything. But it's a little bit tricky to learn, and as you play with that one, you will get all those things, details working through. I'm going to show the Solar Eclipse next on the same software, and then you'll really appreciate that one.
Now, was it connected to the internet always, and so
Yes.
it's always being updated with the latest
Always being updated.
astronomical
Yes,
information?
we can get that part of the story. Yes.
Wow.
And then most of these things are so precise and so definite. Once we develop this part of the software, we can actually go back thousands of years and see.
Well, that's what I was going to ask. It's Christmas. It's the Advent season, right? So I'm just curious. Do we see any particularly significant conglomeration of stars? Let's say a few years BC or something like that you've seen in the software that could be maybe the Star of Bethlehem.
That is a wonderful question, Ryan. Star of Bethlehem.
That's a whole other episode.
We can do the Star of Bethlehem an episode there if Adam is ready for that one. And we also have Betsy here. Probably she can remind us to do that one. The combination of these planetary bodies over 100 years, thousands of years, going back to 4 BC, we can actually see wise men, followed the star, that's what they say, they have seen combinations of these planetary bodies there that are probably visible like one single star because you're a different part of the world. From the east, when they're traveling to the west, you're able to see that one. In fact, last year, 2020 December, we had two of them together again. We got Jupiter and Saturn very, very close. Imagine if you go back to 4 BC and we have Mars also contribute to that one and Venus contribute to that one. And probably that is what they call Star of Bethlehem. They did not know a single one, the combinations of all these things here, which we can delineate right now. In those things they call conjunction, very, very close. You can't tell one from the other because they're so close aligned there. It's possible. It's possible, and we will we'll check into that one very clearly in the next episode. If we have the promise from Joseph that he'll going to join with us, we'll tell the story of the Joseph next time.
Yeah, there we go. There we go. Star of the show right here.
Star of the
One
show.
of the stars.
I had a question on, when we saw Neil Armstrong stand on the moon there, the light there's a shadow there. So is that coming off from the sun? Or?
It's coming out of the sun, and also the shadows on the moon are always confusing because the surface is so reflective. The light is always reflective there because it is a powdery reflective material there. And the clean dust there is not like our red Texas soil there. It is a white powdery material there. So the shadows are always going to be confusing because we have our own spacecraft also reflecting other parts of the sunlight there. Yes.
So Prem, when we look at this, if you're standing on the moon and we look at the sun, do we just see the shape? I mean, that's the circle of the sun, and then everything around it being black. I mean, is the whole sky around it all
the black? Yes, yeah.
And you just see the only where the sun is, it'll be lit up.
Yeah.
Wow.
That's going to be something that you want to go and see.
Beautiful, right? Absolutely beautiful.
That's an amazing thing. Amazing thing.
Speaking about the sample that astronaut collect from the moon, is any sample had any kind of anything match in our Earth?
Yeah, all the elements that we have dissociated from the soil samples we can find on the Earth with the different combinations they are there together.
Okay. That's interesting.
The same thing for the Mars data also. We can find everything. We can create the similar soil on the ground, except for one thing that is called the volcanic ash. Contains this calcium carbonate composition there that is similar to Mars surface that we have noticed so far with the instruments. So they went to Hawaii and there's a volcanic ash field available. They brought that one to Johnson Space Center and mixed appropriately with other things that we know, and they call that one as a Mars simulated soil number 1, and we use that one for all experiments.
Okay, well I've been to Hawaii one time. I went to the Big Island, and as we were driving to our hotel, I felt like I was driving on the surface of Mars. I mean, it was incredible. It had that look and feel to it. It was so bizarre. So it's very interesting that, excuse me, very interesting that they took that and they compared it to Mars or they mixed it with the Mars soil.
Other composition of that one, and in fact, we have done some work on those soil samples, and then we use that one as a simulated Mars soil, simulated lunar dust, also for the experiments there. Yeah.
And it match.
Yeah. We have this based on the data we have from Mars. We created on the ground the samples, simulated sample, based on the information that we actually brought back as a soil itself from the lunar surface. We created on the ground all the similar compositions, and we created a simulated lunar soil because we don't want to use and waste it except for some extraordinary experiments. And we have this one available for all kinds of experiments in preparation of man or woman landing on the moon, or human beings going to Mars one day. Yes.
Speaking of Mars, you guys talking, there was a conversation but not too long ago that scientists believe that at one point the Mars did have the water in there. The way the picture comes up, the eclipse and everything coming up. So is that still in the study point now, or?
It is still a point of discussion and studies all the time, and maybe there is water body underneath the soil layers that we see and we travel around, because even though these rovers, they cannot deep down go and do wells there and so on, so we do not know completely about what is there inside. We can estimate what could be and all those things there, but the surface looks like the channeled by water in one form or another. And also there is a big scar on Mars called Varus Marineris, and that is as big as the United States, continental United States, from California to Washington DC, and that is very, very deep as well. And we don't see any evidence from those things, the data points, what we have there. But on the surface, we don't have any water, so to speak. But we have dry ice, just like we have dry ice that we buy to keep storage and send to mailing things and so on, and the FedEx and all those things there for samples, medical samples or other things there, food sample products.
So
the surface on the north cap and the south cap of the Mars are full of dry ice. That is a carbon dioxide, and those form like that one, but it's not a water related thing. It is just a carbon dioxide. It's very, very cold, and that changes also depending on the location of the Mars around the sun. Sometimes it goes bigger and sometimes it goes smaller. We wanted to land one spacecraft there, I believe in the early part of the 2000, and we missed that one, landing at the south pole of the Mars there. We lost the spacecraft because of one simple reason. We'll talk about that one later. And that could have measured the other contents in that area, could have given more idea. But as of now, we think that there could be water, but we don't have evidence yet.
how about that oxygen? Is any oxygen level in that?
Least amount of oxygen, lot of carbon dioxide. On the Earth's atmosphere, we have more of oxygen, more of nitrogen, and the least amount of carbon dioxide that we can breathe and live through. On the surface of Mars, very least amount, very thin atmosphere. It's only 1% compared to the Earth's atmosphere. So it is very difficult to have that breathing air for us readily available. We need to create, we need to carry, and we need to plan ahead how to survive. On the movies, that is a different story. They can walk around.
So moon had the oxygen.
I'm talking about the movies, the Hollywood movies.
Yeah.
They can create those things.
But the oxygen, moon doesn't have.
A moon doesn't have any atmosphere whatsoever. Zero.
Okay.
It is a vacuum.
So one last question. So on Mars they have storms, right? They have some kind of storms.
Dust
right?
storms, yes, yes.
Dust storms. So on the moon there's absolutely no wind.
No wind. You can generate wind with your aircraft, with your spacecraft. When people were actually driving on the moon, Apollo 15, the longest driven vehicle called the Lunar Rover, they built here, and they carried on the spacecraft. And when they were going through, we can actually see the dust coming out, and we can actually watch those videos too. Yes.
And so the flag that they stretched out and left it like that, it remains just like that.
It remains the same way until
Wow.
you go and disturb that one.
Wow.
And we will know who is going to disturb. Is it going to be Duke or Joseph? We can tell. Who is walking closer?
I'm not going. I'm too chicken. I'll let them go first, and we'll see how it goes.
Yeah, we'll train them to
Yeah,
get
there you
there
go.
safely.
Sounds
I'm
good
also
to
the
me.
same way. I cannot go, but
I'm definitely not going to Mars first. I just not happening.
What happens to the when since it's a vacuum, when atmosphere is introduced there, like what happens? Like even that wind that was generated by the vehicle. I mean, what happens to that wind? I mean, does it?
it dissipates.
Okay.
It dissipates because moon still got the gravity,
Okay.
1/6 of the gravity. So people, if you take an astronaut with 100 pounds, give and take, and then you put about 300 or 400 pounds of the weight on them, and then at the end, they actually have all these pressurized things, about 600 pounds on the surface of the moon to walk around. But they are trying to walk. They're actually leaping and jumping
Right.
because the gravitational force is so
1/6.
light, 1/6 of the gravitation of the Earth. So they are getting bigger steps and bigger leaps there. Even 600 pounds, no matter. On the ground, you have a hard time walking around.
Right.
So on the Mars, it's about 1/3 of the gravitational force of the Earth. So if you are jumping on the moon, say for example 10 feet with a small push, on the Mars, about half of that one, about 5 feet.
Okay.
On ground, 0. You can't
Right.
jump anymore.
Right.
Unless you make an effort there. Okay?
Wow. Speaking about that, I have a totally different question that a month ago, we went to NASA, and as we taking the tour, and they were showing it's a different place have the training. One of the places that he said they put those astronauts in there, and it totally isolated from the whole world. That no phone, nothing at all, dark inside there, just like you go on the moon. They prepared them as mentally how they can. I think it's about 45 days or 70 days they're staying down there, no connection at all. My question is that when that happened, how many people goes in down there, and how many people actually make it out there?
It is a long process for the training. Astronauts have 1,000 plus applications, about 10 of them are selected, about 15, 20, 25 and so on. The first crew members, the astronauts, were only 7 of them are selected. They all happen to be from naval pilots and things like that one. Because those are the people, not only the size of the people, they want to have one unique size that is good enough for the spacecraft to carry, because we can't build, we can't send Joseph because he's too tall for some reason.
No, I mean,
yeah. These people have that capability.
Yeah, but I'm talking about when they go to the training, because it makes you nervous, breaks you everything down.
Yes, yes.
So even they go on the training, how many make it out from those training?
The selection process defines them how many actually make it.
Okay.
And then once they make it there, the training part will be determining whether they can take this particular mission or not. So when they are actually on that mission, again the training continues. For some events, the training could be as long as 4 years. And now the party is going through these various physical parts there, and then sleeping and not sleeping, and not sleeping too long and sleeping too long, and all those things they actually work through, the psychological, the emotional parts of that one. It is not for regular people like me and Ryan. It is for extraordinary people like Duke and
That's exactly what I was thinking. Yeah.
It is physically, emotionally, and mentally is very, very torturous part of that one. And they will go through that one. I will give you a couple of examples of the training there. And there is a unit there where they will keep the body and rotate the body, not just going front to back, in all directions.
My gosh.
And that is going to be a rigorous part of the movements of the body. Brain needs to tell the body, you are going out of control, but don't throw up yet. And now, we need to take these people after they do all these things here. They need to know these things can happen as they jump onto this spacecraft taking off. And now we need to train them how to live and work through in total weightlessness or the floating body condition there. To train that one, they have this spacecraft actually takes off from Ellington Field with all the people, no seats in the back. Because one of the Boeing flight in the beginning, they developed this one. It takes off and goes straight up at an angle there, not just the regular angle that Boeing takes off us in the aeroplane. And we go steep, and then we can actually feel the regurgitation in the body saying that, oh my God, this is the gravitational pull. Not just 1G, 2G, 3G, 5G and all those things. And they go up, and all of a sudden the flight takes a dive and comes down. So these are called the parabolas. Just in our own Gulf here, they do that one. And these people now, no seats, Velcro attached, and they now starts floating there. Apollo 13 movie, when they were making, Tom Hanks came in here, the other crew members, they were all trained in the same way. And they all experienced the microgravity for a while, so they can do that one. They do these parabolas called, for example, they will be flying 20, 30 parabolas, and the bottom line is when everybody starts throwing up, they'll come back.
Wow. Yeah, I also think it's mind-boggling to me that there was the two ladies she's telling that when they come back, that you have to train to walk, how to walk again.
Exactly.
Because they don't know how to walk anymore.
I'm going to answer that one very quickly because that's very important for us to know. And this is only 21 to 26 seconds of time they got to learn. And we actually fly our students as part of this program to connect these equipment pieces so that when we send this equipment to space station, astronauts can connect that one. Will it work or not? Once they are working, will the instrument will work or not? All those things we test on these microgravity or zero gravity flights and so on. Going back to this place, Shannon Lucid was first American woman on Mir station, which is a Russian space station there. Russians, they built the space station there in 1996, and it's there. We don't have a space station yet. So we are trying to dock to that one with our own space shuttle and place our astronauts there. And we have few of them live there for a long time. This is how we determine, yes, we can live in space longer time, not only the Russian body, but the American bodies and other bodies that we train, other astronauts that we train. So we placed them, and Shannon Lucid was probably about 56 years or so. Longest lived in space, the woman at the time. And my daughter is named after that particular astronaut, Shannon. And then when she returned back, we had President Bill Clinton actually landing at the Ellington Air Force on the same day. She landed in Florida, and they'll come back the next day to Houston. And they came, and then when Bill Clinton was about to say thank you very much for your service, for the science that you have obtained after 6+ months, she actually planted seeds and then saw them growing up and all those things. The same seeds when we went to Space Center Houston last week or so, you might have seen the same seeds generation after generation still being grown to know how these seeds actually sprout in space and so on. And she was in the wheelchair. She was in a wheelchair because now the body fluids shift towards upper part of the body, and the bones and other things, they become brittle. At that particular age, even more difficult. So how they will be able to walk again? One of the comments that Dr. Shannon Lucid said was, she was expected to do 8 hours of exercise on a 24-hour basis in the space station. And it's a treadmill with all the other ropes so that you don't fall away, you want to fly away, but to work on that one. That keeps the limbs working when you come back. That's not enough. But you got to go through rehabilitation, going under the swimming pool several hours in a day for about 8 to 9 months. I think she took more than 2 months to actually get better and walk again. And that is the story of the astronauts there.
You got to really want to be an astronaut. I mean, you got to really want it.
And some people, and we have twins there, astronauts. One is a Senate member now, another one is an astronaut. They both were astronauts once upon a time. And this other member was a member of the astronaut called a payload specialist, which means they do experiments there. He lived on our own space station for 1 year. And then we brought him back. So now with the twins being same DNA, we can do studies, one in space, one on the ground. And we got a lot more data to compare with what happens in space. That's another problem. How these things are going to, how long it will take to rebuild the abilities that we lost in the cell structure with the radiation of the exposure. So that is going to be another episode if you remind me one more time.
No, we will discuss, and we'll discuss that thing is any kind of damage does in the physically when they come back. I mean, what is the consequences on it? So that will be another topic.
We'll talk about that one. That is my part of the story that I'm allowed to talk about that one. And we will go into that one. So let me complete this part of the episode here now.
Yes, please.
We got lunar eclipse, and I think you're all convinced that how the shadow of the Earth is going through. So we'll move on to the solar eclipse. So now I mentioned about being aligned to be in the same plane like the sun and Earth and the moon. When the moon is on the other side, we are still in the same plane, yet to move away from that plane, that 5.5 degrees going away. And that part, after 15 days, we are coming on this side from the full moon to new moon. This new moon is going to be here. So the sun is casting all of its brightness on the moon surface, but people on the earth living on this side, looking at the small sliver of the moon having the light there called the new moon. We're not seeing all of the light yet. It is coming in now in this new moon time. Look at the moon is such a small one. When it is casting the shadow onto the earth, is going to be small sliver there. And the small sliver is called the darkest part of the shadow. And then the bigger umbrella that you can see on either side, here and here, is called the penumbra, the brighter part of the shade there, darker shade. And we'll see this one. This is on the December 4th. See now, full moon to new moon is about 14 to 15 days. And we'll get that one. So, lunar eclipse and solar eclipse, most of the times, except it's a small partial eclipse, so we missed that one completely. We'll get that one in about 15 days. November 19th and about December 4th, and we have this one. And this one, where it is, we're going to see that one very quickly here. And this is how it happened. Now I'm going to show the software again. And now Earth is entering into the shaded part here, and it's going to come through. We are looking from the Earth. The moon is obstructing the shade because the moon is creating the shade because it is coming in front of the sun there. As I mentioned before, 1 to 400 in diameters, 1 to 400 in distance. These things work perfectly and precisely to cover the entire moon there. The entire disk of the sun that we see. So that is about half the time there, and then you can actually see it's coming all the way through. You also remember, moon is closer to Earth. Moon is further away from the Earth. When moon is closest to the Earth, it is going to cover the entire disk of the sun. And that's what is happening on December 4th. It is a total eclipse. It's going to cover everything completely. Almost completely. And when it is further away from the Earth, smaller part of the moon, in June time frame, we had a ring of the sun still left out called annular eclipse there. So you got annular eclipse, total eclipse, and we also have partial eclipse. And for some people it's called hybrid eclipse because for us in Texas it may be total, somewhere in South America it may be partial there because they're able to see at a different angle there and all those things there. On the next chart I want you to see and appreciate the shadow of the moon is so tiny, so small, but it casts the tiny spot on that red bright area here at the bottom here. This is South America, and this is Antarctica, this is Africa here on the right hand side. So we are looking as if we have an ability to go all the way to the south part of the Earth and looking up now. And then if you can see somewhere here in this part, you will see part of Australia and New Zealand and so on, all those things there. So this is the tip of the South America. I'm going to show the point there. From there, cruises have started much earlier than December 4th, so that they can actually enter this area of the ocean called the Southern Sea, south of Atlantic, south of Pacific, we call Southern Sea there. And that is the cast of this shadow is going to go through on top of this Antarctic continent and come back here. The whole thing is only a few minutes. The cold coverage of the moon in front of the sun is only a few minutes. Whereas the shadow of the Earth for moon to pass through is hours. This is what we are going to see and appreciate this one. And the small sliver of the shade that we are going to see here. As on my next slide, I have the arrows for you to see where the darkest part of can be experienced there. So there are cruises here, and my colleague Mr. Karnik from my university actually booked this cruise like 2 years ago, and good enough, they are able to go. Only 194 people, they actually went there, and they actually were waiting for the shadow of the moon passing over them. And Mr. Karnik is an astronomer, and that is his passion for his lifetime, and he has seen most of the solar eclipses. I said, I will not go there. I will wait here and wait for the picture to come to me. And we got that one too. People on this Antarctica, about 100 scientists were there. They've been waiting for about 6 months now just to watch this beautiful setting with the moon in front of the sun, and they got the pictures too. I'm going to show that one to you. On December 4th, from Antarctica, one of the scientists actually sent this picture to us.
Oh, wow.
You can actually see the sun being completely covered with the moon surface there, and you are missing the whole thing of the sun there for a fraction of time, and it will be very, very dark in this particular region because the shadow of the moon is going to be on the ground as well. For them, they actually experience it, and we have a lot of videos about that one, and you can actually see that. But this is a total solar eclipse that happened just now, last week or so. I will show you something very interesting here. In this particular area, in the southern part of Antarctica area, in the month of June we had on the northern part, starting with northeast Michigan and then Canada and other places they could see in June, partial eclipse. Now, in the later part of the year, December, we are seeing from the southern part of the Earth a small sliver there. Look at this one. Last time they were able to see in this region was November 23rd, 2003. If you go back from December 4th, it was exactly 18 years and 11 days.
Wow.
So if you want to see, and if you want to go live, we will send Joseph one way to live in Antarctica. He needs to wait there for 18 years and exactly 11 days to see this eclipse again there.
So it'll be December 15, 2039.
December 15th, 2039. Where do you see that number there? Oh, here it is, December 15th and 2039. I would like to go there, and I would like to volunteer my son to go with me because that is his birthday too.
Oh.
18 years and 11 days. Can you imagine the 18 years, 11 days now going forward, 18 years, 11 days backward? And you can actually see this 18 years and 11 days all the way through to have this eclipse happening there. Do you remember I mentioned something like 18.85 years for the moon to come back to the same spot, 5 1/4 degree? All those things play an important role to get these numbers so precisely for us. And this is what the Babylonians called an 18-year cycle. And this particular eclipse is called once in a generation, because 18 plus 18, 36, you got to have next generation coming up. And that's what it is. This is called the Saros there. If you hear the name Saros, the number 18 years, and this is where it is coming from. So that is the eclipse part of that one. And this is the fascinating picture of the moon covering the entire surface of the sun completely. From the same Antarctic area that we have seen, the total solar eclipse on December 4th there. So next time, 18 years from now, both Duke and Joseph can go there and verify whether we are right or not, Ryan. We're going to stay here and wait for their live call from there.
I'll be sipping my hot mocha, and while they're on the surface of Antarctica, hopefully having some mocha themselves.
Sure,
if
we're
it's
probably going to be with Walker, right?
Yep.
possible to get it there. But I admire those people that were willing to, because I just think, you're on a ship in Antarctica. Something goes wrong with that ship. I mean, I don't know, that makes me a little queasy thinking about that.
Yeah, of course.
So, if I'm in the Caribbean or Gulf of Mexico, or even in the, Atlantic, that's one thing, but...
You've been to Hawaii, so that life is different there.
It is. It is very
Speaking about
different.
Hawaii,
Great coffee, by the way.
The one you saw, that the whole thing under lava, looked like a...
yeah, like Mars.
Mars. So, before that, me and my wife, and we all went down, they just started, and it did it up at that time. We went too close by, that whole lava was coming too. And the town we saw, and when that happened, the upshot that happened, the whole town went under lava. And I still have this picture, the old town is not there anymore, it's gone.
Yeah.
Used to be, it was a church, old church, almost, I don't know how old they said the church. The whole church, whole town is gone.
Those things are there.
Yeah.
Even Italy we had recently, and I've seen that one too. So we'll do one episode on just the volcanic
In fact,
things
I
happening.
have this picture. I bought the video from that town.
Wow.
And and right before that, so the whole town is gone. So I still have the whole town in the picture.
My goodness.
So I'm going to bring Tyler second. Show those clips, from that,
Oh yeah, that'd be great. Fantastic. So, Dr. Prem, is this the end of your presentation?
I
Do you
have
any more
only
slides?
one more slide.
Let's
That is
do
the
it.
take-home message, and then we'll conclude here. This is
Great.
what it is. So this is especially I prepared this slide for Betsy. Because every full moon is given a name for each month, Betsy. And these are the names that in the November month we call the Beaver Moon. Next month, December 18th, if you want to ask a question of your friends on your Facebook, the name of the moon is called Cold Moon, easy to remember.
Wow.
And then a wolf moon, snow moon, warm moon, pink moon, flower moon in May. And we had a lunar eclipse in the May time frame called the flower moon, that is a full moon. And now we had a partial lunar eclipse, November 19th, is called the beaver moon. And these are names given long time ago. And there's a corn moon too. Maybe they get corn there. Strawberry moon. No wonder in the month of June you will see strawberries all around the world.
Strawberry moon.
Strawberry moon. That's
There
what
you
it is. The name was given. the seasoning for this and the season time for the harvest things, strawberries and things like they actually follow the moon cycle, lunar cycle, so to speak, to get the best of the things and so on.
So who gave those names?
These are ancient astronomers. They looked at the moon and said, "Oh, we're seeing the moon in the month of this one. We call it harvest moon. What are we doing? Harvesting in October time frame." So that's how they, probably about 16th, 17th century, the names were given, and we follow the same thing here. It's actually called Farmer's Almanac. That is the name of the book that have these names of the moon. And they actually give when to seed, when to wait, when to how long to wait, and come through. So all of you, please remember the next moon is called cold moon because it is a moon in December. Very easy to remember. Here are my final thought. I will just give one final thought for all of you. We're looking at the Earth. We looked at the Earth being so precisely so far away from the sun. We did not talk about what happens if the Earth is closer to the sun and away from the sun yet. We'll talk about that next time.